Hey, welcome back to RamZland. Today I want to show you a couple demonstrations that illustrate atmospheric pressure and density. Check it out. All you need for these demonstrations is just a bottle with a cork and some tin foil and a ping pong ball and some water. Preferably do both of these demonstrations over a sink. Okay, for the first demonstration, just fill a bottle all the way to the brim with water and then take a ping pong ball and put it over the mouth of the bottle like that. And then tip the bottle upside down and you'll see that the ping pong ball stays attached even when it's upside down or sideways. Even if I shake it, the ping pong ball doesn't come off. And this is because there's more atmospheric pressure outside the ball than there's water pressure inside the glass. So it's air pressure that's holding it on there. Let your kids shake it over a sink and you'll see that the ball just doesn't come off. And there's no glue on it, it's just air pressure. For the next demonstration, fill a bottle all the way to the top with water, take some tin foil, and wad it up into a small ball that'll fit through the neck of the bottle. I think that's probably about small enough. So once you put the cork on top, the essential question is, what makes the tin foil dive? If I press down on the cork with my thumb, the tin foil goes down. If I let my thumb up, watch what happens to the tin foil, up it goes. This is because there's tiny air pockets inside the tin foil. And if I press down on this cork, I'm forcing water into those little pockets and the tin foil becomes more dense and it dives. But then if I let up on the cork, the little pockets of air inside the tin foil expand and push the water out, making it less dense, so it rises again. If I press down, water fills the tin foil, it dives. If I let up, the air pockets expand, push the water out, it becomes less dense and rises. All you need for these two demos is a ping pong ball, a glass of water, a cork, and some tin foil for experiments with atmospheric pressure and density.